Number 5 on the growth and decay worksheet. At time t, the volume of a sphere is increasing at a rate proportional to, so that means dV dt, proportional to k times the reciprocal of the radius. So 1 over radius. Okay, I've got extra variables in here. I've got v's and t's and r's. I've got 3 variables. I don't really like 3 variables. At t equals 0, the radius of the sphere is 1. And at t equals 15, the radius is 2. Find the radius of the sphere as a function of t. At what time t will the volume of the sphere be 27 times the volume at t equals 0? At what time t? 27 times 1 would be 27. So, okay, but the main problem is I got r's and v's and t's in here. So it would be nice if there was some relationship between some of those variables. Do you know what the volume of a sphere is? 4/3 pi r cubed. So I'd probably like all my v's to go away. I'd probably like everything in terms of r, since that's what most of the problem is. So I would like to replace dv dt with something with r in it. So how about I come over here and take a derivative. dv dt would be, multiply the 4/3 by 3, that's convenient, 4 pi r squared dr dt. So yeah, I can see why number 5 would be tricky, because it has this extra equation thrown in there. So in place of dv dt, we'll put 4 pi r squared dr dt. Equals k times 1 over r. So yeah, number 5 is very different setup than the others. Okay, let's separate the variables. So algebra, how am I going to get this r to the other side? Especially the 30% of you that didn't do it right way on the warm-ups. How's this r going to get to the other side? Let's multiply both sides by r. So 4 pi r cubed dr equals k dt. I need to decide where I want the 4 pi to go. I can leave it there, or I can put it in the denominator on the other side. I think I just leave it there. It's not going to matter, but I think I'll leave it there. So the integral of r cubed would be r to the 4th over 4. So that was a great plan to leave it there, because now 4's cancel. Kt plus c on the other side. So pi r to the 4th equals kt plus c. Now we start. So r and t are the variables, k and c are the constants, but I've got 2 pieces of information, so I should be able to get these constants. So pi times 1 to the 4th equals k times 0 plus c. So c equals pi. pi r to the fourth equals kt plus pi. By the way, I'm doing this a little bit different than I've done the others. I'm not solving for r, I'm finding c and k first and just leaving the r to the fourth there. Because I think it's easier this way for this problem. Next, let's plug in 15(2). So 15 in for t, and 2 in for r. 2 to the fourth. 2 cubed is 8, so 2 to the fourth is 16, so that's not as bad as maybe we thought it would be. Rigged problem alert, because what's k equal to? Pi. So now I know c, I know k, so my formula then is pi r to the fourth equals pi t plus pi, which is kind of weird. So why don't I just divide everybody by pi and be done with pi? R to the fourth equals t plus 1. And the question was, find the radius of the sphere as a function of t. Okay, well I don't have it as a function yet, so I need to solve for r, the fourth root of t plus 1. And then lastly, at what time will the volume of the sphere be 27 times the volume at t equals 0? So when r is 27, find t. How about 27 to the fourth minus 1? I don't know what 27 to the fourth is, but it's really big. So I'll leave it at that. So that one was tricky at the beginning because there was extra variables in there, and so you needed an extra equation to handle the v's and the r's.
The test.
I don't think there's one that bad on the test. And I don't think this 5b, I don't think that's right. Right? I got this right. What time t will the volume, well, the volume of the sphere, not the radius of the sphere. Tricky. Be 27 times that at t equals 0. Alright, let's stop there, because that's terrifying. Volume, not radius. So it was not, I'd have to go do some more algebra, basically.